Students have come up with a new topic of alcohols and phenols. So alcohols and phenols of class 12th grade chemistry. And from this chapter, I have taken preparation of alcohols from alkenes. Sometimes you get a question in the board exam, subject to question. Write the mechanism of acid catalyzed hydration of alkenes. Some of you get confusion in this topic. So how the mechanism of acid catalyzed hydration of alkenes takes place. So if you want to understand the formation of alcohol from alkenes, unsaturated hydrocarbons, how the unsaturated hydrocarbons are converted into alcohols. So let us discuss a detailed mechanism of acid catalyzed hydration of alkenes. So by acid catalyzed hydration, is done for alkenes, symmetrical and unsymmetrical alkenes. So generally this reaction takes place. Addition of water to the alkene in the presence of acid catalyst. Acid catalyst, we can take sulfuric acid. So acid catalyst you can take. So the sulfuric acid active like so catalyst we say, and for the protonation so of the double bond, protonation of the double bond. So let us look into this reaction in detail, and if the alkene is unsymmetrical, it goes as per the Markovnikov rule. As per the Markovnikov rule, where the negative addendum moves or the nucleophile moves towards the carbon, high degree of carbon, or the carbocation having less number of hydrogen atoms. So as per the Markovnikov rule, so what you have studied in the 11th class, the previous class, Markovnikov rule, so that is. And if you see this alkene having the unsaturation center double bond, so which has the pi electrons. So the unsaturation center, when reacted with water in the presence of acidic medium, we can get alcohol. And so if you take example propene in the presence of water, so means when water is added to this in the presence of catalyst, acid catalyst, we can get propane 2-al, we get according to the Markovnikov rule. And if you look into the mechanism of the reaction involves the following three steps. The first step is the protonation of alkene to form carbocation by electrophilic attack by hydronium ion. The hydronium ion is H3O+. So how this hydronium ion is formed? So when water molecule react with acid, acid proton, so the water molecule react with H+ ion to form hydronium ion. That hydronium ion act as an electrophile H2O+ H+ and forms H3O+. So the hydronium ions, once it forms, it has electrophilic property, and so this hydronium ion is added to the double bond pi electrons, the unsaturation center. So the pi electrons will be given to the proton of this hydronium ion. So where the hydronium ion changes into the water, then the proton is added to this carbon. So the water molecule is formed here. Then the means so in the first step, the carbocation is formed. Carbocation is formed. The step 2, the nucleophilic attack of water molecule on carbocation. Once the carbocation is formed in the first step, so then the water molecule, which act as a nucleophile, attack the carbocation. So, and when the water molecule lone pair of electrons from the oxygen given to the carbocation, so there is a positive charge is formed on this water molecule attached to the carbon, and this positive charge is compensated by the deprotonation process. So deprotonation process, means the deprotonation, the base molecule of acid. So when the acid molecule undergoes dissociation, proton is added to the water to form hydronium ion, and the bisulfate ion, if you take H2SO4, HSO4 minus will be abstracting this proton. Then the sigma bond of this electron is converted into lone pair. So then we get the ultimate product, alcohol. So let us see. Step 2 is nucleophilic attack of water on carbocation. So the water molecule act like a nucleophilic nucleophile, and since it has two lone pair of electrons, one lone pair is given to the carbocation. So then on this oxygen, so there is electrophilicity is formed, so positive charge. So in order to compensate this positive charge, the sigma bond is converted to lone pair, and so this proton is taken by bisulfate ion, HSO4 minus subtracting this proton to form so acid again, so in the form of catalyst. So that is what we call step 2, deprotonation to form an alcohol. When this this proton is taken by the bisulfate, which is released from the acid, and so forms into alcohol, and this bisulfate, that means bisulfate will form, this proton is taken by the bisulfate to form H2SO4 or the sulfuric acid. Acid is again reproduced here. So in this mechanism, as catalyst is again reproduced, catalyst is produced back. So the deprotonation, and the deprotonation is done by the, so facilitated by the, so bisulfate ion of the acid molecule, or or the water molecule take up the proton to form again so hydronium ion. So this hydronium ion combined with the bisulfate ion to form so acid. If we take another example, so look at this structure. This is 1-methyl cyclohexene. 1-methyl cyclohexene is the cyclic alkene, and so to this compound, if you add water in the presence of acid catalyst hydronium ion, and we can get 1-methyl cyclohexanol we can get, so according to Markovnikov product. So according to Markovnikov product, we can get 1-methyl cyclohexanol is being formed, and so now let us look into this mechanism of the reaction, how this shows that cyclohexanol, 1-methyl cyclohexanol is formed. Now, same mechanism we can apply. So what we have discussed earlier, this first step 1, electrophilic attack of hydronium ion to the alkene. So then formation of carbocation takes place. So carbocation intermediate formation taking place. So which is a slow step we say. Now look at this, the 1-methyl cyclohexene. So means double bond is, that means the protonation or the electrophile hydronium ion is attacking this double bond. So that double bond means the protonation is done to the double bond. That means the pi electrons given to this proton, and the bond breakdown takes place here, and the sigma bond is converted to lone pair. So then what we could see, the proton is added to this carbon, then so carbocation is formed. So this is 3-degree carbocation, which is more stable. So we say H2 is a byproduct is formed. And step 2, water react with the carbocation. So when water molecule react with, because water molecule act as a nucleophile since it has 2 lone pair of electrons. So the water molecule attack this carbocation, and so one lone pair so use it for the making bond between this tertiary carbocation with oxygen. And so on this oxygen, since one electron pair is used for making bond, so this positive charge is compensated by loss of proton. Then that step what we call deprotonation to get neutral product, which is a fast process and which is a spontaneous process, we say. And the proton from this, proton is taken by the water molecule, and the water molecule changes into hydronium ion again. So this hydronium ion is the proton of the acid, we say proton of the acid. So that means acid catalyst is again reproduced back. It is produced again. So then the product we get is a stable product. So that is called and 1-methyl cyclohexanol is a product is formed, and acid catalyst is formed once again. So, so this is the mechanism of acid catalyzed hydration of alkenes mechanism we can follow. So where the water molecules so added to the unsaturation center in the presence of acid catalyst. So and so in this process, the formation of alcohols, the stable products we can get. So based on the degree of carbocation is formed. So degree of carbocation, already you know that so 3-degree carbocation is more stable than the 2-degree, and 2-degree carbocation is more stable than the 1-degree. According to the stability of the carbocation, so that formed in the reaction intermediate as a reaction intermediate. So the carbocation will determine the formation of alcohol. The carbocation is having high stability, and if it is 3-degree, so and 3-degree carbocation, so tertiary carbocation will give tertiary alcohols, and then more stable than the secondary alcohols. Secondary alcohols are more stable than the primary alcohols, we say. So the attack of the negative, so addendum takes place according to Markovnikov rule. So and so this is about the mechanism of acid catalyzed hydration process of the alkenes. Thank you so much, everyone.